Hi, my name is Lisa Harlow, and I am presenting on the youngest Toba Tuff super eruption from 75,000 years ago. The youngest Toba Tuff, or YTT, is located in Indonesia in North Sumatra. It is now a lake and a mountain. It is the largest super eruption that occurred in the Quaternary period in the late Pleistocene. It has a VEI of 9, and that's due to how much material was expelled, 3,800 cubic kilometers of dense rock and 1,500 cubic kilometers of pyroclastic flow. This covered 40 million square kilometers with a greater than 5 millimeters of ash. This location is marked by the red star, and it occurred because of these plates coming together. As you see, there's the southeastern Indian Ridge to the southwest that's spreading, which is causing the Indian Australian plate to subduct under the Eurasian plate. This subduction causes frictions between the plates, which causes earthquakes. The subduction is an increase of pressure, which causes dehydration, which melts magma to create chambers of magma stored for eventual release. On the right, you can see a cartoon from our lectures that shows a mid-ocean ridge spreading with the subduction underneath plates, creating arc volcanoes, dehydration of that subducting plate, and chambers of magma for release from the volcanoes. This super eruption has been extensively investigated over the years, but there was a recent study that I wanted to talk about, which used local earthquakes and mapped the S&P wave velocities and how they changed as it moved through the Earth. In the bottom graph, it shows the P anomalies of the wave velocities and the S anomalies, where cool colors show increased velocities and warm colors show decreased velocities. Then they use this information to make a 3D picture showing the subduction of the plate and the way that the morphology looked on the top, and then also used one of the cross sections superimposed onto the wave velocity changes to show water dehydration that occurs from 70 kilometers to 90 kilometers below the Earth, and then creating a magma chamber in the mantle that fuels shallower pools, which then is creating the explosive super eruptions. The impact that this super eruption had on Earth has been debated over the years. Early proposals actually even thought that humans were completely decimated as a result. It is thought now that there was an extreme impact on human evolution because of this super eruption. This is a graph of a model of how deep the ash was stretching from the point of eruption. This ash has been dated using potassium argon pairs, uranium thorium pairs, and also oxygen isotopes from different areas, both in the ocean and on land. It's made of predominantly andesite and rhyolite. The plume is thought to have reached the stratosphere, blocking the sun from sulfur aerosols, reducing the ozone, and also the ash could have increased productivity, injecting carbon dioxide into the ocean. The temperature range change is from like 0 degrees Celsius to quite large, 12 degrees C. It's just conjecture in different regions based on the wind at the time and what sort of atmosphere that was happening. But this study of these super eruptions can aid us in how to anticipate the effect that eruptions could have on climate and life on Earth. Here's a list of my references if you would like to learn more. There's a couple of videos and also some pretty good papers.